Assalamu alaikum guys. Today we will discuss about the polycarbonates. It is one of the important polymers. So let's first discuss its synthesis. How can we synthesize the polycarbonate? For this purpose, we just need the three things: bisphenol A, also known as BPA. This is a bisphenol A. Its structure is simple, having two benzene ring, two OH group, and there are the two methyl group. So this is basically a bisphenol A. Now this is a phosgene, C double bond OCl, and there is one more diphenyl carbonate. There are two phenyl groups like benzene rings, also known as the phenyl groups. So that's why diphenyl and CO3. We know that the CO3 is the carbonate, so diphenyl carbonate. When we will take these, then there is a basically a formation of the polycarbonates. So this one is the structure of polycarbonates, PC. We can say PC as polycarbonates. So what is happening here? Can you see that this these these two, see the BPA, these are the benzene rings, same like that as in above, CH3 okay. So basically what's happening here, can you see this hydrogen has replaced with a C double bond O there, and their hydrogen also has replaced, and this chain will continue in the same way, but we just need up to here, and we can see that COO, and there is one more O. It's mean this is also a CO3 in this structure, CO3, like 1 2 and 3 O. So this is also a CO3. We called it polycarbonates. So this is basically how we synthesize our polycarbonates. We just need a bisphenol A, phosgene, and diphenyl carbonate, and this is polycarbonates. Now this remember some important points here. This one I have written here. uh, this is basically a ester interchange reaction, and the diphenyl carbonate, this one that we are using here, we can get the diphenyl carbonate from the carbon monoxide, okay. And from where we can get the carbon monoxide? We can get the carbon monoxide from the carbon dioxide. So can we see, can we say this this synthesis is greener, like related to green's chemistry, okay. So that's why these are the some points that you must have to remember about the polycarbonates. Now let's move toward the next, that is basically a melting point. So the melting point of the polycarbonate is 225 °C, but now it has decreased to 195 °. But how? Remember one thing, we have a these two pendant groups are methyl pendant groups. So if we have methyl pendant group, it's mean melting point is 225. But if the pendant group is replaced with some bulky group like ethyl group, or you can also place propyl group as well. So we know these are the uh, flex, flexible groups, like the groups which will provide some flexibility to your polymers. So when we will introduce these groups, definitely its melting point will be decreased, okay. So and why it has 225 °C melting point? Because there are the two benzene ring, and we know benzenes are the stiffening groups, okay. So it makes the polycarbonate stiffer. So now we have replaced our CH3. We can Not in this, we can replace. When we will replace these two groups with propyl group, definitely melting point will be 195. Now move towards the properties. So these are the tough one, hard. They are hard, they are tough and transparent plastic. Have you ever noticed the bottles in your home? The 90-liter bottle that we use for the water that we bring from filters. So that big bottle is basically made up of polycarbonates, okay? And the CD's compact disc also made up of polycarbonates. So these things are the tough. It's difficult to break the CD. You must have to provide some sort of the force to break the CD. So there is an aromatic ring in the polycarbonate. So this aromatic ring will increase the stiffness. Why this aromatic ring will increase the stiffness? We know because the aromatic group is a group which will provide the stiffness. Okay, I have told this point again earlier, few minutes ago. So definitely, what will be the TG? TG will be higher. Okay, as we know, when there are stiffening groups, then TG will definitely be higher. It require we have to provide the more temperature for the chain mobility. And notice that the feeders and the feeders that we use for the infants, babies, is made up of the polycarbonates. So we should avoid this. Why we shouldn't use this? Because it can cause neural and behavioral changes, okay, in infants and children. So as I have told you earlier, this method is greener. But why I'm saying that we should not use it for the baby bottles? Because this bisphenol A, this one monomer can also present in the polycarbonates. As we know, in the condensation reaction, some sort of the monomers still left, so it might possible that you have a polycarbonate bottle, but there are one or two monomer of PPAs still present, so it can cause neural and behavioral changes. So this is all about the polycarbonates. So if you have any question related to this, kindly comment and like, share and subscribe my channel. And for more videos and for concepts, please write in the comment section. I will try my best to reply you. Thank you.